says we're recording. And there you go. All right, so 5.1, we're going to start with numbers. And I'm going to fix my handy dandy document cam. And now I do realize that some of you invented numbers and some of you, was there when the first numbers were invented. But I'm going to teach to those students that have always had problems with numbers. So the people that invented numbers, you just stay home and be quiet and create a cure for cancer and COVID. Okay? So, numbers. There are two types of numbers. There is your prime numbers, and there is your composite numbers. Now, let me go ahead and tell y'all something right now, because I know I have some people that know everything in here. The reason I'm going over this real slow is because this leads to prime factorization. I'm going to just write a little note down here. This leads to prime factorization. And that leads to LCL and greatest common divisor. And that leads to this least common denominator. Which leads to adding and subtracting fractions. Which I think this is 5.3. Now, the reason I'm showing you this is I know I have a couple of people in here, like I said, that invented prime numbers and invented composite numbers, and they think they know it all, but that's not what I'm teaching. What I'm teaching is this for this, because this is where everybody sucks as far as math goes. Everybody sucks at adding and subtracting fractions, all right? So my goal is not 5.1. My goal is to teach you 5.1 so you don't suck at 5.3. All right, that's my goal. So I'm going to go through this stuff in 5.1 real slow so that way you don't suck at finding the least common denominator in 5.3. So that's my goal. So I'm telling you that because I don't want the student that knows everything to think that I'm only worried about this. No, my plan is to get you ready for 5.3. All right, prime numbers are what I call the ugly numbers. Because the only numbers that'll have anything to do with them is 1 and the actual number. Now, the definition for a prime number is a number that's only divisible by 1 and the number. So what numbers are only divisible by 1 and the actual number? Let's write that in another color so that way you can know that's important. Anybody want to give me a list of the prime numbers?
3.
1, 2, 3. Good. What else? What
7,
else?
7, 11, 13.
Okay, 5, 7, 11, 13, 17, 19, and so on. Now you could actually, and this is a good thing to do for the 1 or 2 people that will actually do it, go to your Google and type in list of prime numbers. There you go. And you can print that out for the 1 or 2 people that will do this. You can print that out. I'm sorry, I accidentally clicked on it twice. I hate when they do that. And you can print that out, save it, print it out. And there is your purple prime numbers. Now, what is a composite number? Everything else. So all you got to write down for a composite number is numbers, everything else. First, everything else. Because a composite number is a number that's divisible by other numbers. A number that's divisible by other numbers. And that's everything else. So you take your handy dandy, and that's 44, 4. Now 1 is supposed to be a prime number, but there's some teachers and some math books that do not include 1, and some teachers and some math books do not include 2. But as you can tell, both of them, and I include both of them, 1 and 2. And a lot of people say, well, Hubert, why don't you just say they're the even numbers? Because 2's not even. And there may be some more even numbers, not here on this chart right here, but to infinity, there may be some more even numbers that are not. But most of them, I will give you this, most of them are odd, but not all odd are prime. Because here's an odd, 35, 45, 49, 75. Those are odd, but they're not prime. Okay, so let's write down the ones that are prime. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, and so on. And you can't say, well, all composite numbers are even. 15's not even. 9's not even. So you can't just generalize. Do not generalize prime numbers and composite numbers. Now, prime numbers are very important. So what I would like you to do is I want you to highlight the prime numbers. I want you to highlight these, or just that word there. And I don't know why that got all dark. It let out too much ink. Sorry about that. All right. Prime numbers. Prime numbers are what we're going to focus on all the way up to 5.3. Now, what do you mean focus on? Well, once you learn the prime numbers and the composite numbers, you learn how to factor. God, that went all the way through 2 or 3 sheets of paper. It let out the ink. I don't know. Something must be wrong with that highlighter. It's a conspiracy. All right. Factorization. Does anybody know what the word factorization means? Anybody? Anybody want to take a stab at it?
Break down into factors.
Good job. Break down into factors. I'm going to turn this off. Maybe it'll save a little bit of bandwidth, because I know there's a lag in my document cam. All right. Factorization is breaking down to factors. Breaking down to factors. That's what factorization is. There's regular factorization, which is usually, whatever. And then there's prime factorization. And that's breaking down to prime factors. So let me give you an example. Let's say I asked you to factor 54. What will 99% of you break 54 down to? Go ahead. That means I want you to interact with me.
27 and 2.
Oh, come on. Are you telling me that you don't think of 6 times 9 whenever you think of 54?
Yeah.
Okay. Most people think of their multiplication tables. Most people. 6 times 9. And that's called composite factorization. Now, Mr. Nelson suggested 2 times 27. Well, 2 times 27 would be the first part of your prime factorization. Okay? 2 times 27, and then 2 times 3 times 9, and then 2 times 3 times 3 times 3. Therefore, the prime factorization of 54 is 2 times 3 to the third power. And that's what we're going to focus on in 5.1. We're going to focus on prime factorization. So from here on out, I don't want anybody to mention a composite number unless they're writing it down as part of prime factorization. So if I ask you, what is the prime factorization of 24, nobody should say 6 times 4 or 3 times 8. Now, if you say 3 times 2 to the third power, 3 times 2 times 2 times 2, that's okay. Or 3 times, or 4 would be 2 times 2, and then 2 times 3. I want you thinking in terms of prime factors, and here are the prime factors that everybody should list on these problems. 2, 3, 5, 7, 11, and sometimes 13. Those are the numbers that you're going to be working with in 5.3. 5.1 and 5.3. 2, 3, 5, 7, 11, and 13. So if I ask you, how many times will 2, or how many, what do you break 12 into? The first thing you should say is 2. Nobody should say 6. Why? Because 6 doesn't exist in our universe. You're going to have to be thinking in terms of prime factors. 2 will go into 12 6 times. 2 will go into 6 3 times. 3 will go into 3 1 time. When you get that 1 right there, you have your prime factorization. 2 times 2 times 3, or 2 to the second power times 3. That's your prime factorization. So your prime factorization of 12 is 2 to the second power times 3. Now, let me go ahead and tell you, I use the chart here to do prime factorization. I don't use trees, because when you use trees and you get to the least common multiple and the greatest common divisor, you can't do the tree diagram with the greatest common divisor and the least common multiple. So I don't teach the tree diagram. I teach this. And if you try to use the tree diagram in the last part of 5.1 homework, you might get the answer wrong because you're going to get confused. For those people that said, well, I'm going to use the tree. Okay, go ahead. But when you get to least common multiple and greatest common divisor, you're going to get confused unless you've learned something that I don't know about. So let's do a couple of examples to get everybody in the mood or get everybody in the, whatever you want to call it, habit of using these 6 numbers. So here we go. I want you to give me the prime factorization, and I'm writing all this out so you're used to it. Prime factorization, I can't talk, of ... 144. Now remember, 2, 3, 5, 7, 11, and sometimes 13. All right, now I want you to do that. I want you to write 144. I want you to draw a table. I want you to put 2, 3, 5, 7, 11, and sometimes 13. And I want you to break this down until you get a 1 on the bottom. All right, go ahead and do that. And we'll give you about 30 seconds. And if you can't do it, that means you're a failure and you should probably quit and quit school and live in a ditch. That's what my father always said to me growing up. If you don't, that's fine. Don't study. Don't do your homework. Therefore, you'll, quit school eventually and live in a ditch. I know, my father was terrible. No, he wasn't. He just told me the truth. Anybody had a father tell you you're going to live in a ditch? And nobody's going to talk to me. Okay, that's fine. We'll just make the class drag out as long as possible. Or somewhere else. Told you live somewhere else? A shelter. Okay. Well, mine actually said you end up in a cardboard box living in a ditch. That's what mine actually said.
No.
Well, he also said this. He also said, we are a product of our own decisions / choices. I never asked him where he got that from. I don't know if he made it up, but the older I get, the more I believe in that. Miss Lacombs, was that a yawn? Did you just yawn in my virtual class? I am hurt.
I'm so sorry. I usually keep I'm so sorry.
That's all right. I'll just probably quit my job now.
No.
Thank you. I'll probably start drinking after this class.
Oh, no,
that's awful. Don't do that.
Yeah, don't do that.
I hope it's coffee you're drinking.
I'm a bourbon drinker myself, or moonshine. Which all you have to do to turn moonshine into bourbon is to put it in a wooden barrel or put wood chips in it. But anyway, all right. So here we go. 2. We'll go into 14 7 times and go into 4 2 times. Now, if you suck at your multiplication tables, you're going to suck at this. So you better learn your multiplication tables, because I do not condone using a calculator for this. Now, all of you, none of you have your video on. I don't know if anybody used their calculator to divide 144 by 2, but you should not have to do that. So don't say anything. Just take it for what it's worth. I will tell you when you need a calculator, and this basic math, 5.1 through 5.3, nobody should be using a calculator. Okay? 2, that's an even number. Let me show you a trick I learned in the war. Let me go back to Google, and let's type in divisibility table. And you're going to have to, divisibility. Oh, look at there. I don't even have to type it in. There it is. And I want you, if you suck at division and multiplication, I want you to print one of these out. This is probably the best one right here. If the last digit is 0, 2, 4, 6, or 8, multiples of 2, then it's divisible by 2. If the sum is divisible by 3, then the whole number is divisible by 3, and 9, and 6, sorry. Okay, so you need to print this out and put it on an index card. And I bet you $1 some of you have never seen this before and been through 12 years of school.
I have not.
Nope.
Exactly.
Never seen that in my life.
I wouldn't doubt it. Oh, Miss Hunter decided to turn her video on. Thank you, Miss Hunter.
I actually have my phone on, and I had to set up my computer because it keeps telling me that it keeps coming up with an error.
Okay.
I've actually seen that disability table.
It's a privilege to see you, Miss Hunter. I wish the rest of the class would do that, but they suck. So you don't suck, Miss Hunter. All right, so 2 will go into 72. 2 will go into 7 3 times. That'll leave a 1 remainder, which would be 12. 2 will go into 12 6 times. 2 will go into 3 1 time. That'll leave a 1 remainder, will be 16, which will be 8. 2 will go into 18 9 times. 3 will go into 9 3 times. 3 will go into 3 1 time. So the prime factorization of 144 is 2 to the 4th power times 3 to the 2nd power. And that, I'm sorry, that is how you do prime factorization. I always get somebody to ask this question after I show prime factorization. Well, what if I started with 3 first? You'd still get the same answer. Because 2 times 3 is equal to what? 3 times 2. Multiplication and addition is commutative. So you don't, it doesn't matter what order you put this in. So you can divide by 3 first if you wanted to. You would still get the same answer, which is right here. I always get somebody to ask this question. Well, Hubert, I got the right answer, but I didn't do what you did. Well, when I get to least common multiple, greatest common divisor, you're going to have to do it the way I want, or the way I do it. Because there's no other way that I know of that you can get the greatest common multiple or the least common multiple, greatest common divisor. All right, so I'm just warning you, please just try to work with me here for those people that want to go off in another direction. Question on this one, because you know I'm going to give you another one. I'm going to give you 3 examples right here, and if you can't do them, that means you suck at it. You need to work on it. All right, so here we go. Let's try 1200. Just like the tequila, right? Oh, Hubert, you're bad. All right. I think it's 1200, isn't it? I'll have to look that up. All right, y'all get to work. 2, 3, 5, 7, 11, and sometimes 13. Give you 30 seconds. Yeah, 1,200 tequila. I thought there was one called 1,200. Oh, it's 1,800. I was wrong. It's 1,800. Not much of a tequila drinker because tequila makes you do crazy stuff. So I stay away from tequila. Dang old tequila makes your clothes come off. That's a song. So don't try to get me in trouble by saying, Hubert's talking about taking clothes off. Oh my gosh. That was a laugh. Somebody laughed. Heaven forbid. Other students are going, she shouldn't laugh at him. She shouldn't do that. All right. 2 will go into 1,200 600 times. 2 will go into 600 300 times. 2 will go into 300 150 times. Change gears. Actually, you don't have to, because 2, you could start with 5, or you could start with 3, or you could stay with 2. What's half of $1.50? I'm sorry, 75 cents. So half of 150 is 75. Somebody just went, oh my God, I never thought of it like that. Miss Grindle, you look like an operator or a DJ, one of the two.
Oh, it's my gaming headset.
What happens? Miss Grindle goes off the air. I mean, Miss Grindle comes on the air with her video, and Miss Hunter goes off the air. Y'all got something worked out where one of you comes up, Miss Hunter just disappeared.
I've had mine on, but my camera likes to not work sometimes.
Okay. All right, so now I'm going to switch to 5. 5 will go in there 1 time and 5 times. 5 will go into 15 3 times. 3 will go into 3 1 time. So my prime factorization of 1,200 is 2 to the 4th power times 5 to the 2nd power times 3. Now, if for you, all you OCD people, you can turn that around and say 2 to the 4th times 3 times 5 to the 2nd. Somebody's calculator is doing, I mean, somebody's video or
yeah, mic is picking up. It's hurting my ears.
What'd you say?
So someone's mic's like messing up. It's hurting my ears.
Yeah, you need to get your stuff straight, y'all. I'm trying to see, usually when a sound comes through, it lights up whoever's is coming through, but I've got 2 or 3 people I can't see. So if y'all will look whenever it does that, everybody take your microphone. If you've got an external microphone or external headset, make sure wiggle the plug to make sure it's in the computer so it won't make that noise, because sometimes that makes that noise. All right, so let's do another one. Let's do the prime factorization of 1,500. And I start y'all off kind of easy because I want you to crash and burn, and that way I can really discourage you when you get some wrong. I want you to get the big numbers. You crash and burn, I can really kick you in the stomach. 2, 3, 5, 7, 11, and 13. All right, take another 30 seconds and do that. Evidently, somebody has a short or sensitive plug because I don't hear it anymore. Good job. I'm awesome. Okay, what time is this class over? 1:15?
I think it's Hunter's mic.
Okay. Miss Hunter's mic?
I think so.
Okay.
Because it goes off whenever she turns her mic off.
Oh.
I don't know. Because it was working. It was working earlier when you first plugged it in.
Miss Hunter, we're gonna kick you out of the class.
I went back.
All right.
To my phone. I brought a new computer today. And
Uh-oh. It must be nice to have. It must be nice to have money. I tell you what. All right. 3 will go into 1,500 500 times. For those of you that don't have a sense of humor, that's a joke. Okay. It must be nice to have money. That's what people. When I grew up around here, that's what people say when you get something new. Must be nice to have money. Okay, some of y'all swinged on a pickle and parents don't teach you that. You don't know what I'm talking about. All right, 5 will go into 500, 100 times. 5 will go into 100, 20 times. 5 will go into 20, 4 times. 2 will go into 4, 2 times. And 2 will go into 2, 1 time. So the prime factorization of 1,500 is 2 to the second power times 5 to the third power times 3, or 2 to the second power times 3 times 5 to the third power. It doesn't matter what order you put them in. I know some of y'all will be like, oh gosh, why can't you put the 3 in between them? You can. And that is the first, that's the base right now of chapter 5. That is your foundation right here. If you can't do prime factorization in a timely manner, you're going to have problems when we get to LCM and GCD, which is the next class, which will be Friday. Okay? Now, right now, you're not responsible to have 5.1 homework all done. Right now, because I haven't finished. 5.1 includes prime factorization and LCD, LCM, lowest common multiple, least common multiple, and greatest common divisor. So I've got to finish before now. What should you be doing for homework tonight? Keep doing prime factorization. If you find some homework problems in 5.1 of prime factorization, do them. If you run into least common multiple and greatest common divisor, stop, because I haven't covered it yet. Or you can go to study plan and work on 5.1 prime factorization as much as you want to, and then wait for me to say do the homework on 5.1 if you want to do that. I don't care what you do, but do something before Friday. I don't want you to go home. I don't want you to stay at home and not work on something. I want you to do prime factorization on some problems before Friday. Because if you can't do the problem, I want you to send it to me so we'll have some examples to do for Friday. Okay? But you're not responsible for 5.1 homework yet. Anybody got questions? Okay, well, you're welcome to leave whenever you want to, unless you got questions. And I will see everybody Friday virtually. Oh my gosh, there's Miss Roberts. Oh, there she went. I shouldn't have said anything. Dadgummit. Y'all have a wonderful day, and I'll see y'all Friday. I'm going to hang around.
Thank you. You too.
In case somebody's got any questions. See y'all.
Bye. Thank you.
Bye-bye.
So you said not to do the homework for 5.1.
You can, just don't do it all. Just do the prime factorization problems. Oh, there's Miss Mia.
Mejia, you said it right the first day.
It is right, Mia.
Mejia.
Okay.
Yes.
Yes.
I have a question too.
Okay. Right now, I want you to focus on prime factorization. You can do it several ways. One, you can go into study plan 5.1 and just do prime factorization, or you can just go to your homework and just do prime factorization. You can go to homework and do prime factorization because it'll have find the prime factors. It'll have it in the directions. and then go do 5.1 study plan all you want. You can just make up some. But right now, 5.1, to complete 5.1 homework, no, I have not finished 5.1. So right now you can just do prime factorization in any application you want to do it. I just want you to do some before the next class. I want you to do maybe 3 or 4 or 5 or more of prime factorization in study plan or in the homework, but don't do anything more than prime factorization. If the directions say find the least common multiple and greatest common divisor, don't do it. Does that make sense?
Yes.
Okay, what was your question, Ms. Mejia?
I was just gonna ask, how do you know which number to use? Like 2, 3, 5, 7, 11, 13. How do you know
This
which
right
one?
here.
The divisibility rule. Oh no, the prime numbers.
Rules right here.
I had it right the first time. Yeah.
Okay.
Why do you have a trash bag behind you?
I just moved and we just got our windows done. We have no curtains.
Oh, okay. I didn't think about that. I thought you were trying to cover up something.
Oh
like
no!
a poster or
Literally,
something.
all our windows have trash bags on it.
Oh, okay.
Maybe
Well,
because
I guess
that's
I
spotty
guess
hanging there.
that's like living in a box. So Miss Mejia is living in a box. She lives in a cardboard box. All right, Mr.
Hopefully,
Pat,
as soon
you
as
have a question.
during the semester, we'll have actual blinds.
Okay. Mr.
All right.
Pat, do you have a question?
Yeah. So, can you like kind of go over your method again?
Yeah. Let's go over. Let's do another problem. Let's do the prime factorization. Hold on a second. Let me get my, there we go. Let me present. Prime factorization. Why didn't it share? Oh, I was sharing. I'm sorry.
You turned it off.
Okay, I turned it back on. Let me know when you see it.
It's on.
Okay. Prime factorization of, pick a number. Pick a number between 1 and 2,000. Let's start.
190.
190. Okay, so I'm going to do this, and I'm going to put 190 here, and 2, 3, 5, 7, 11, and sometimes 13. Now, Mr. Pack, don't feel bad because for every 30 students I teach in Math 155, 10 to 12 of them have never seen this before.
I've seen it, and like I said earlier, I saw the rule. It's just I am very math illiterate.
Okay.
And
I feel that.
I would normally have my dad go over this with me and explain it, but he's not here to do that anymore.
I understand.
So
mine passed away in 2014, so I understand. 2, now you look at the number, and like I said, this helps if you would print this out, and you can pick any one you want. I got them all over Google, and this one ends in 0, so you know automatically it's an even number. Okay, it may not look it, but it is. So I'm going to go with 2 first. Now you don't have to. You know it ends in 0, it's divisible by 10. So you can do that one also. But 10 is not a what? 10 is not a prime number, so you can't use 10. But you could do 19 times 10 and put the 10 over here. You could do that. So I'm not gonna, split hairs. The most 90% are gonna pick 2 because it ends in 0. So I'm gonna use 2. So 2 will go into 19. Let's see. 9 times 2 is 18, so that'd be 9.
95.
And that'd leave 10, that'd be 5. Now, let me go ahead and tell you this, Mr. Pack, because you said you're math illiterate. Some people, the only reason they're math illiterate is because they don't know their multiplication tables. And they have gone through K through 12 not knowing their multiplication tables. Let me tell you, I have tutored people in the 11th and 12th grade, and their only problem was that they didn't know their multiplication tables. Once they knew their multiplication tables, they could do fractions, and then once you can do fractions, you can do algebra. And I'm just telling you the way it is. Most people that have trouble with this don't know their multiplication tables. So when I do 2 into 9, 19, 9 times, and that leaves a 1 right here, that's 10. 2 will go into 10 5 times. They start to freeze up. So 5, this ends in 5. So I know it's divisible by 5 because of my divisibility rules.
I think your camera's frozen. There's nothing's working.
It is.
Oh, shoot. What's the last thing that you see?
Your hand and then 190 above it.
Yeah, you didn't even write the 2 or anything after that.
Okay.
That's what you see.
Hold on a minute. Let me present screen again, and maybe it'll unfreeze. Hold on. Present. Let me know what you see now.
2 and the 95.
Okay, good. All right. Let me make sure. Oh, shoot. I'm still recording. Shoot. Thought I turned it off.
It said you did earlier.
Well, I don't know why.